Hi, Elizabeth. I just wanted to show you the answers to those last two problems that you had for homework that we couldn't get through. And I did my homework and my research, and then I found it, and they're both actually very easy. The first one, we had to solve for A, given that we had a line tangent to the parabola. Sorry if my video is moving around. But anyway, there is a special condition for this. If you have a parabola and you have a tangent to the parabola on one point, then it means that you only have one real root. And the only way you can have one real root when you have, if you use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. This will give you two roots because you'll get the positive one and you'll get the negative one. The only way you can have one real root in this particular condition, because they tell you can only have one real root if this happens, is if this b squared minus 4ac under the radical is equal to 0. Because then that all goes away and you're just left with negative b over 2a. So that's a really important point, because then all you have to do is you have to set b squared minus 4ac equal to 0. And then you have to solve for your b, your a, and your c, and we don't have that yet in this condition, but we know that y is equal to x. So I can substitute the x in for the y and get x is equal to ax squared plus 6. And then I could subtract the x over and get ax squared minus x plus 6. And now I have my a, b, and my c. My a is just a. My b is going to be negative 1. And my c is going to be 6. So then I can go back to the formula, the discriminant. That's the thing under the radical. B squared minus 4ac. And for b, I can plug in negative 1. Square it. For a, I put in a, and for c, I put in 6. For the discriminant, I get 0 because I want my answer to x. I want my root to come out just one answer, so it'll be negative b over 2a. So I have to eliminate this whole thing. So that's why my discriminant's 0. When I do this, I get 0 equals 1 minus 24a. And then if you just subtract 1, this is all just algebra, you get negative 1 is equal to negative 24 over a. And then when you divide by negative 24, you'll get a is equal to 1 over 24. So that was the answer to that first problem that we couldn't figure out. And so you would just put negative 1, or you'd put 1 over 24 in for a. So I'm sorry that we didn't get to that. The other one was they gave you this problem. The second one they gave you, I'll write it over here. The second one that they gave you was you're given this equation, y is equal to x squared plus px plus q. And they tell you that the smallest value it can have is 0, so it can't be smaller than 0. It has to be bigger than 0. And that's the same idea. If you have a parabola and it can never be less than 0, but it could equal 0, that means that it must just be touching at one point. And if it's touching at one point, again, it's one real root. It could have a multiplicity of 2, like it could be an x minus 3 times x minus 3, but it's one real root. And if it's one real root, again, that means that the discriminant has to be equal to 0 so that you just get the root negative b over 2a instead of it takes care of the plus and minus, which would give you two roots. So you do the exact same thing. You set your discriminant equal to 0. I hope this wasn't on your test, because now that I know how to do this, it would have been nice to show this to you. You'll have to tell me how it went. Anyway, this comes out to your b is p. So that's p squared minus 4 times a, which is 1, and your c is q. And I believe the question asks for you to put p in terms of q or q in terms of p. let's do P in terms of Q. So I'm going to add this stuff over to the other side. So I'm going to say 4Q, because negative 4 times 1 is 4, and that's negative 4Q. So I'll bring it over to the other side. 4Q equals P squared. So P is just going to be equal to the square root plus or minus the square root of 4Q, and that would be the answer. If it's solved for Q in terms of P, then you just divide by 4 and you get Q equals P squared over 4. So that's how those problems are done. The key to both of these problems was just knowing that if you have a quadratic that can't be smaller than 0, that means the maximum value or the maximum number of roots is 1. It might have no real roots. It might be up here somewhere, but it can't go down below the x-axis. So therefore, the discriminant had to be 0. So you just set the discriminant equal to 0 and solve it. With this one up here, if you have a parabola and you have a line that's intersecting the parabola, then it can only have one real root. So the way that we ended up solving it is we know that they intersect at this point, so we set the lines equal to each other. And then after we set the lines equal to each other, I just brought everything over. Now we have a parabola where we can identify the A, B, and C. And then we have to say, okay, if it has one real root, the discriminant's equal to 0. So I just plugged in 0 and then the A, B, and C values based on this new equation that we came up with. And then that was able to solve for A. So that's how those two problems are done. I don't know if you need them or not, but I just wanted to share the video with you because I felt like you lost out a little bit during the tutoring time. So if you want to be tutored again this week, just let me know, okay? Have a good day. Bye.